exactly what to do here, but we'll see how it goes. So I'd like to introduce myself. I'm Mohannad Hussain, and it's always funny when my introduction slide is actually not prepared by me, it's prepared by Brad, my good friend over here. So I'm a software engineer by training, and that's what I still like to think I am, but unfortunately these days I'm also stuck doing team lead stuff. I also am very active in the SIM community, and if you don't know what SIM is, it's a organization in North America. Do I have to? Okay. So SIM is an organization in North America that's more concerned with education and imaging informatics. So you probably hear a lot about RSNA. You know, SIM is another organization that holds a conference as well, but SIM is a lot more focused on education than they are on sales and big deals and flashy press releases. So we'll get right into it. I'm not sure how many of you know DICOM, just like the fundamentals. Okay, not too many. You don't count, Brad. I'll quickly go through this. We've covered this in other sessions, but I figured if you've come to this session and you haven't been exposed to DICOM, you probably need to know the basics. So what is DICOM in medicine? It's really the images. So HL7 Fire, HL7 V2, V3, they're all concerned with the majority of the workflow. But when it comes to imaging, DICOM is where you go to. It defines how you store images, how you transmit images. It defines a whole bunch of workflows specific to imaging. So it's a smaller part of the bigger workflow, but it's a very important fundamental part. So what happens is, and I'm definitely oversimplifying this, you know, a modality here is acquiring images, so CT or X-ray, whatever you've got, and it's going to send them to the archive, okay? Now, typically this archive is going to be the PACS, so picture and archiving and communication system. Some customers may, down the line, and again, simplified workflow, store these images long-term in what it's called a VNA, a vendor neutral archive. And we're just starting on the acronym soup here, so bear with me. There's more and more coming. But I figured this way, if you encounter these acronyms later on, then you know what I'm talking about, or what somebody else is talking about. So then, once the images are stored, then the radiologist is able to access them. Of course, it depends on how they're accessing them. So if they're accessing them for reporting, it's usually done right against the PACS. But long term, if they're looking for priors, then these images may actually be coming from the VNA. Typically, a PACS or a VNA will speak the traditional DICOM, so that's sometimes called as DIMSE, D-I-M-C-S-E. That uses cfind for query, and that's basically the name of the transaction. cmove for retrieval, and then cstore for storage. And again, simplifying things quite a bit here. There's a lot more to it, but just keeping it very simple. Now, a lot of you may have heard of WADO, and in this case, this has actually been retroactively renamed to WADO URI, and that's basically a way to do a web-based call to retrieve DICOM objects, one object at a time. So this is the middle point, but then comes modern DICOM, which is DICOM Web, and that basically defines a set of transactions that can perform what the old systems used to do, but with newer, more modern methods. They're all web-based. So you have Kido RS for query, which basically replaces cfind. And then you have WADO RS for retrieval, which replaces both cmove and WADO URI. And STO RS is storage. Anybody lost? Everybody still on track? Good. We'll quickly zip through these. So DICOM, again, storing images. It's all kinds of images, whether these images are actual radiology images or other things. So it could be things like pathology, it could be things like actual pictures taken with cameras. You know, think about dermatology where they take a picture of your skin. Long lists, and these images come in wide varieties. You know, some of them can be black and white, some of them are color, some of them are pre-processed, some of them are post-processed, some of them come in 8 bits, some in 12, some in 16. It's pretty complicated. If it was just a matter of storing pictures, we wouldn't need DICOM, but there's a lot more to it than what meets the eye. The other thing, of course, that DICOM helps with is that we're not just storing pixel data. DICOM actually stores a whole bunch of information. And the whole idea of it is that if one day someone just gives you basically a file, then you've got all the information you need to link it to the proper record in the file. You don't have to have anything separate. It's all together. Okay. Other things that DICOM also stores, we usually just talk about images, but there's actually more to it. So key objects are very interesting. Key objects is, to simplify it, if you're a radiologist and let's say you're looking at a CAT scan, that CAT scan could be as many as 1,000 images in series. You may want to simplify it as a radiologist for the clinician down the road who's going to look at the report and pick one image that shows exactly what you want to describe. So you mark that image as a key object, and then that object essentially stands out from the rest. So that's one thing. Or you could actually do the opposite. You could mark an object to say, this object is bad quality. This shouldn't be shown to anybody. Along with images, you could also store what is known as GSPS. It's an acronym, but we won't bother because it doesn't mean much. Really what it is if you draw things on the image, DICOM doesn't like to alter any existing data. So when you draw things, whatever you draw is stored separately from the image. They're shown together, but they're stored separate. It also stores the state of the image the way you liked it to be. So if you change the brightness and contrast, or if you've turned the image around, all that can be stored in GSPS. So how does DICOM actually work? How does it actually store these things? Well, it all starts at the patient level. So you have a patient. Patient has studies. Okay? So maybe, today I'm doing an X-ray. Last year I did a CT. These are my studies. Okay? Within the studies, you have a series. And the series, in this case, could be, let's say, for example, I did a multi-procedure image. So let's say a CAT scan with, let's say, different views. So then each one of these views could be stored as a separate series. Okay? Or if it's, let's say they took an X-ray of my wrist. They may take it like this way and then this way and that way. These are all series. And then within the series, you can have one or more instances. If it's an X-ray, it's typically one instance within a series, but if it's a CT scan or MRI, there's usually a whole bunch of series because they usually play essentially like a movie. They play sequentially. So once again, there's a hierarchy here. And then at each level, we've got some very interesting attributes. This is a very short-handed list here, just to show. And basically, the most important thing we want to look at is the UID. So you see study UID, series UID, instance UID. That's DICOM terminology, basically, for unique identifier. And keep in mind, the last one, we usually, we've been talking mostly about images, but here we're calling it instance. This is the more correct term because the instance could be anything. It may actually be an object that you could show, but it may actually just be a metadata object. For example, like when we talked about key object or GSPS, things with markup, so it could be something invisible. And of course, at each level, it stores information that is relevant. So for example, for the study, it's the date of study, the description, which typically is mapped to the procedure code, and things like that. Any questions about this before we leave it? Okay. More terminology for you. We won't focus too much on this. You don't need to memorize any of this, but basically, you got to think of DICOM of when this was written, back in the 80s. A lot of things were different. So, for example, if I just jump to the middle, you see it says service class user and service class provider. That's what we today call client and server. That's basically what it is. And then, things like service object pair. If you ever work with DICOM, you'll hear people talk a lot about SOP instance UID, SOP class UID. That's what the SOP is. It's terminology. It doesn't mean anything fancy. It's just stuff that people like to throw around because it's the convention in DICOM. Okay? But then really the most important one here is actually the bottom one, which is AE, reference to application entity. So the way that DICOM devices talk to each other is typically over TCP/IP. But when they do talk, the authentication or handshake in DICOM is done through what is called an AE title, which is basically knowing each other by name. So if I know someone like, let's say, Brad here, it's one thing if I just say hi, and it's one thing if I say hi, Brad. Because hi, Brad means I know you. And then if you respond saying hi, Mohannad, then that's basically the handshake. We establish the handshake. It's the same thing with DICOM devices. Let's say the modality goes to the PACS. It says hi, PACS by its proper name. And then the PACS respond. That's the handshake. They know each other. They can actually perform transactions together. And of course, the other thing when I talk about the DICOM being developed in the 80s, the way that the data is represented and stored is something that was really designed in the days when this information would have been stored on tape. And sequential retrieval, don't think about what we have today, you're spoiled, because today you can look up anything in an object right away. But back then, if you're just sequentially retrieving, you have one piece of information at a time. You're pulling like a string and you don't know what you're going to get next. So that's why DICOM is actually designed with this tag terminology. Each tag has an identifier, which is essentially 2 numbers. The first number is usually the group, and then the second number is the individual tag. So patient name is 1010, and referring physician is 890, so on and so forth. They're hexadecimal, and the way is, these are usually stored, and then at the bottom of the file you have the pixel data of the image, if there's an image in that file. Okay? And again, remember, this could be on tape, and this could be an image that is hundreds of megabytes in size, one individual image. So imagine if, in the 80s, you were actually pulling this and slowly processing it. The other thing is, you might be thinking, okay, well, the 80s, but we're in 2017, why do we care? DICOM is actually backwards compatible all the way back to day one. No, not 100%, but very, very close. So that's pretty nice to be able to maintain the backwards compatibility. Because keep in mind, when a customer buys something like a CT scanner, this is not something they're going to keep for 2 or 3 years. It's not a laptop. It's a lot more expensive. This is a device they're going to keep for 20, maybe even 30 years. All right. Now let's do some hands-on. If you would like to bring up a laptop and follow with me, you're more than welcome. But if you'd rather just watch and try this on later, whatever works for you. Okay, so to get some hands-on going, we need a few things first in place. So first, you need some DICOM images, some actual samples. There is no shortage of samples on the internet, but these are my favorites right here. So the Sim Hackathon dataset is one option, and there's a URL that takes you to it. And my personal favorite, which is very relevant to the conference here, is that this one actually is really 2 data sets, not one. There's a Fire data set and there's a DICOM data set, and the 2 line up together. So this is a really nice data set in terms of being real world-like. Like if you were in the real world, your HL7 data would line up with your DICOM data. And this is what this is doing. It's actually emulating it. But then if you're just looking for just images, any images, and maybe like a wide variety, the Cancer Imaging Archive is a good one. So that's an initiative out of the States where they have, I don't even know how many studies, it's quite a bit. There's no shortage of all types of modalities, and it's all in the name of cancer research, so there's no shortage. So those of you who are following, let me know when you're good, when you're done typing the URLs, and I'll move on to the next thing. Maybe I should walk you through it really quick. Sorry. Here. So if you are looking at the SIM data set, the URL should actually bring you to this one here, Hackathon Images. So if you've seen this, then you can click on any of these patients. There's 5 patients. You can click on any one.
Could you show again
the
URL?
Yeah, sure. Just one. Oops. Yeah. Once you have it open, let me know. I'll show you how to get some images from there. Did you manage to get it? Yeah, so you can click on any of these patients. Is this better? So here you have a bunch of patients within the SIM data set. You click on any of them, it will actually show you the studies they have within. And then you click on the study, that will show you, it's actually split into the series too. But then eventually when you click through, you can click on pretty much any random order. because whatever directory you end up in, it will have some DCM files, which is short for DICOM, which is what you see here. And then you click through on the actual DCM file, and then you'll have an option for download here. Look, GitHub thinks it's an executable file. All right. What I'm going to do is I'll just move on very quickly to the next slide. Now, remember what we said. These DICOM files at the end of the day are images. So the next step in the process would actually be to get an image viewer and try and look at these. So here, again, you have multiple choices. My two recommendations are Micro DICOM, which is a Windows-based viewer. For those of you who are on Macs, you have other options. I think there's Horus and Osiris. But there's also a web-based one, which is Cornerstone. And this one's actually pretty nice. So any of you who might be looking for a medical image viewer for a research project or something, it's a highly recommended viewer. It's very nice. Very modern, too. Those of you who are following on their laptops, if you just give me hands up when you're good, so I can move on to the next slide. Okay. Should also mention Cornerstone is open source too. You're good? Okay. So I happen to have Micro DICOM already installed. I'll open it up, and then we'll open up the file.
Download. Huh.
Yeah, it's a little tricky. Some of these websites are not very nicely designed, and sometimes it's hard to find the download button. Okay, so I have downloaded 3 sample images here that we'll show, just to show you what they look like. So I'll double click on the first one. The first one here happens to be a mammogram. So again, a viewer like Micro DICOM, it's nice because it just shows you the image. But if you ever have to show this image yourself, you will find that it's pretty significant effort. So first of all, this file here was actually 26 megabytes. This is just one image. And this is in fact not really that big. A lot of mammograms can be a lot bigger. I've seen mammograms as big as about 1 gigabyte. So it can be very intense. On the right-hand side here, you see the list of DICOM tags. I know it doesn't look very nice on the screen right now, so I'm not going to go through them. But we'll go through them somewhere else in just a moment. But anyway, you see, if I scroll down, the list of metadata is very, very long. That's the right page. For those of you who are actually trying to install Micro DICOM, usually that pane is small, so you may want to stretch it out a little bit to be able to see. But again, this is one of the reasons why DICOM is good with imaging, because you see all this metadata that allows us to get more information about the image, more information about the study, the patient, all in one place. So less chance of misplacement, less chance of things going wrong. Okay. Let's try another image just to see. So we've got one here. I don't remember what modality this one actually came from. I think this is a localizer image for a CT scan, I believe it was, something along those lines. But anyway, within a DICOM viewer, some of the things you could do, forgive me while I find it here. So yeah, here for example, you could do things like measurements. And you notice, a little hard to read actually, but the measurements in my case are coming up as 203.6 millimeters. And again, this is one of the advantages of the DICOM, because with the image, it actually stores information about the projection of the image, so how far the patient is from the actual machine, and therefore we can map it to real world values. So when you're making measurements on the image, we can actually give you the measurements in real world values. Like, you know, if you're measuring a tumor that, let's say, is 2 centimeters, it will tell you that it's 2 centimeters. So again, one of the many things that DICOM can actually do because of all the metadata being there. Of course, we talked about markup and annotations and things like that. So here's an example as well where you can put text on the image. Like for example, you could take a measurement and you could put a note next to it saying, here's the tumor, or something along those lines. The possibilities are endless.
That's not 20 centimeters.
Sorry?
The measurement is
Yeah, I know in this case it is wrong, but it's anonymized data. That might be the reason why. Yes. It's not real data, right? It's mostly sample.
Just a very short person.
Of course, the other thing that you can actually do is, in this case, you could flip images, rotate them any way you like. Sometimes the images are not captured right, so you need to modify them last minute. Sometimes they're actually captured flipped. And there's one more thing, but I actually can't seem to remember. Oh yeah, there it is, Windows level. So let's switch this image back. So window level is essentially DICOM talk for brightness and contrast. It's not exactly the same, but it's close enough. So if this is me trying to do window level, when I press and hold, moving left and right will adjust one of the two, brightness, contrast, and then up and down changes the other. So go up here. I guess this is not really a good image. Let's open up another one. There's a better one for this sample that will show better. Yeah, here's an X-ray. And let's do some window level on this one. So I press and hold. It's not a great example, but sometimes adjusting the brightness in window level helps you see things better. So for example, if you want to see soft tissue versus, let's say, bones, or the other way around, that's what brightness and contrast is usually used for. Okay, any questions on this before we move on? No, it's all clear. Now, if you want to work with DICOM, a viewer is just good for seeing images. But if you want to know more or do more, you will then need a toolkit. And the toolkit then allows you to do things like actually do queries against the fact system, or extract more useful information out of the images that you have, or even modify these images if you need to. Sometimes you download images, and let's say you need to anonymize them. So this is a common use case where you may need a toolkit for that, okay? Now the toolkits come in all shapes and sizes here. So this list I'm giving you here, that's essentially my favorites from a very, very long list of toolkits. And I should also mention, if there are any developers in the rooms, a lot of these toolkits are open source, and there are even more libraries that are open source you could use. So if you want to incorporate anything into your code, there's always something out there, okay? I'll just quickly go through them. If any of you want to download, the first one I usually would start with is DVTK. But you're more than welcome to try any and see which one you like the most. Everybody has a preference. I was hoping to do more. Time has gone by really fast. And then this is how we configured Ginkgo. I was going to do more. So DCM for Che, the toolkit, by the way, also has a bunch of other commands you could try in the future if you're interested. So DCM to XML will take the DICOM object and dump it in XML format, which then you could parse with something else if you wanted to, or just a bit more human readable, since that output was a little cryptic. And of course, DCM to JPEG will convert from DICOM to JPEG for you, which is very convenient because then it will do all the processing required for you. The image will come out nice and visible. Okay, Daikon Web is the next iteration. As we were talking, you've got basically these services. So query is KeyToRS, retrieve is WADORS, store is StoRS, and then there's the modality worklist, which is UPS. Similar structure to Fire, you could also do capabilities. So you ask the server, what can you do? The server responds, I can do this, this, that. Here's an example of what it looks like. We'll zoom through these really quick. So you ask it for studies for this specific patient, and you can provide the query using either the DICOM tag or the actual name. So in this case, instead of 00101010, I could say patient name equals, and it would do the same thing. There is the name format there in DICOM. And then that's the server responding here. It says, I've got these 2 studies for that patient. That's basically one way of doing things. I'll move through the rest here super quick. So WADO, again, retrieval through the web. That's how you make your request. So typically you'll start by searching for what you need, and then once you find the identifiers, which is 1.2.3, and then 4.5.6, then you can actually use that to retrieve. So these are the guaranteed unique identifiers, because things like patient ID and accession number are not guaranteed to be unique. You need to find the unique identifiers in DICOM, so study UID, maybe series UID, and maybe instance UID. Okay? Storage is done similarly. So you could post an object to the server stores it. We'll ignore this one here in the interest of time. There's a nice cheat sheet that Brad has kindly created. If any of you are interested in DICOMweb, please go take a look at it. It's just DICOMweb.org. If you search for DICOMweb cheat sheet, I'm sure it will be the first result on Google. It's probably the only one out there. Okay, so for a Fire audience, how do you put the 2 together? How does this work? And again, we'll go through this really quick. So a typical workflow goes like this. Patient comes for a visit, an order is generated, they decide on the protocol, they acquire the images, the radiologist actually generates a report, and then other clinicians, other doctors, the patient can access their images and reports later. If we were to look at the Fire objects involved, you see there you've got encounter, care plan, procedure request, et cetera, et cetera. The link between Fire and DICOM is right here, imaging study. That's the link that connects the 2. So typically an imaging study in Fire will have information on the DICOM study. It may actually have the UID of the study. Sometimes it may even have a URL that you could just call. Like it'll tell you right away, go to this URL, you'll get this, which makes life a lot easier. So let's say you've got a Fire server, you send this query, give me all the imaging studies for this patient. So then it responds, here are the studies. And then your response could essentially look like this. So you see the 3rd line from the top, it has the UID. That's the DICOM UID. So that's the study UID. Then you can go and take this to the PACS or the VNA and say, I want this one. And you know that you're going to get the exact same one because this is the unique UID. It's guaranteed. And then you see over here, it's got the address. This one is actually a fake address. It doesn't have the UID. But if it had this data element, then this should take you right to the study. There should be no fiddling or any additional guessing required. Okay? Down below, it usually will list the instances. So it's listing the series here, and then it lists the individual instances. I'll be honest, I don't think it's relevant there, but nonetheless, it is there if you need it. We would have done some hands-on, but we're out of time. If anybody wants to do some, I'll still be around today, so please come and find me. I'll try and be around the imaging table. I think with that, questions? Yeah, go ahead.
What would you recommend for structured reports?
In what sense?
I mean, you could use Fire also for structured reports. They are very complicated, right? They
Yeah.
Very often have private tags.
Yeah, I'll be honest, it's a bit of an open-ended question, so I don't really have a specific answer for you. All I can tell you is that I've seen many people do it many different ways. And yeah, I mean, some people will usually keep it out of the VNA, some people do store a copy in the VNA. Rod, do you have any specific thoughts?
No, I'm kind of almost of the same opinion.
Yes.
There's lots of different ways to do it. You can do it in DICOM or you can do it in Fire. It depends on the use cases, unfortunately.
Fire it with,
Pretty streamlined. In Daikon Web, it also works well.
yeah.
Because you can get it as XML and JSON as well, so you can parse it out as well.
Which tool would you recommend? To enter it in a report and start to do it?
I would like DCM for check. I use that to connect it up to whatever I'm actually developing.
Yeah.
So I've used the libraries from that toolkit for that purpose.
We will have to wrap it up because we're out of time. I apologize, but we got to make room for the next.